Welcome to Lab 8 for Physics 187. This week we will also be finding the mass of stars, but this will be for stars for which we cannot actually distinguish them as two separate stars. This will be an example of an eclipsing binary, where we can tell that the two stars, or that we're looking at a binary system, because as we look at the light coming from those stars, we see a brightening and dimming of that light on a regular basis. And by looking at the light curve, how that light brightens and dims, we can actually identify that this is a binary system. And by looking at how much time it takes the light to return back to its original value, to start, have one star pass in front of the other to dim the light, and then have the other star pass in front of the first to dim the light yet again, and return back to that original point, will give us information about the period of the orbit. Right? These two stars are moving, we see light from both of them. Now the light dims because one of them is in front. We continue to move around in an orbit, and the light will dim again as the other star comes in front. And now we're back to the light just beginning to dim again, and we know now the two stars have gone through a full orbit. Sorry, I can't twist my wrist, so I had to cheat a little bit. What we'll do today is we'll use the fact that we can measure the speed of the stars, once again using the Doppler effect, and also that by measuring how the light brightens and dims, we can actually get a value for the period, how much time it takes those two stars to complete an orbit around each other. Okay. Using that information, we can then find the mass of those stars. Notice the equation looks very similar to what we had last week, except now the sum of the two speeds is squared. And rather than having a radius over here, we have the period, and we're now dividing both sides of the equation by 2 pi. So we can measure the speeds of the two stars, we can measure the period by looking at the dimming of the light, and using that information, we can figure out the mass of the two stars. We'll find the speed of the two stars as we've always done using the Doppler effect. We'll find the fractional change in wavelength, we'll multiply that by the speed of light, and that will give us the speed of the stars. Unlike last week's lab, where I originally told you you'd only have to look at 2 wavelengths and then actually showed that you need to do 4, this week, because we're doing more binary systems, you'll only need to consider 2 wavelengths for each of those stars. Let's go ahead and look at the lab and see what we see when we open up the lab. You'll get a view of the sky that consists of a number of binary systems. As I hover over a star, notice that you'll see a red line which gives you the value for the light intensity. And for this particular star, notice that light intensity actually changed. So this tells me that I am on a binary star. If you click on that star while that light intensity is showing, you'll be able to see both the light intensity and the spectral lines, and this will be helpful in helping you calculate the period of these stars. Okay. Notice, as we're looking at this, we can see the spectral lines changing. It's very important when you're measuring the speed of these stars that you're measuring the speed as they're moving directly toward you and directly away from you. If you're measuring them across their line of sight, you'll get a value for 0. And that's not an accurate reflection of how fast the stars are actually moving in this orbit. So when you measure the Doppler shift, you want to make sure that these stars are at their spectral lines are at their farthest out point when you make that measurement. I'm going to stop them very quickly. I know I've missed the point, but I'll just stop them and say, okay, let's assume this is the right point to make the measurements. One of these lines represents star 1. One of these lines represents star 2. Okay. Just make sure you're consistent. The more massive star, as you should have observed from last week's lab, is typically going to be moving slower, and so it will have a smaller Doppler shift, right? So the larger Doppler shift from the green line will correspond to the same star that has the larger Doppler shift for the violet line. So make sure you're being consistent on those shifts. One star should always have the larger Doppler shift than the other. So I'll measure this. I'll measure over to this one. This is about 1.3 for, let's call this star 1. This is about 2.3 let's call that star 2. Okay. In this particular case, star 2, because it has the larger Doppler shift, would be moving faster and would correspond to the lighter star. You would do the same thing for the violet line, and you can actually then enter the numbers into the spreadsheet for this lab. Notice how this is spread out. Binary pair 1 would have star 1 and star 2. You'd again just simply enter the number of divisions for the violet, for star 1 and for star 2. Enter the number of divisions for the green, for star 1 and for star 2. Again, remember to be consistent. If star 1 has a larger violet shift, it should have a larger green shift. If star 2 has a smaller violet shift, it should have a smaller green shift. You will do this then to find the velocities for binary pair 1. To find the period then for this particular system, turn on your animation and make a note of when the light begins to dim. You can get some help with that because you know as the lines start moving closer together, the stars are beginning to block each other. And so when that light first began to dim, you should note the time in the clock. Okay. Notice it brightens, so now the two stars are away from each other again. I'm just going to continue to watch this animation. We'll make sure it's going very fast if it isn't. Notice the stars the Doppler shifts are decreasing, which means the stars are now beginning to move across each other, and the light dims again. This is now the second star moving in front of the first. You would not pay any attention to that, right? Because we haven't gotten back to that original orientation. And so now, the time you're looking for is when the light begins to dim for the third time, right? So the first time began the orbit. The second time was the other star moving in front, and this third dimming that just happened would be that time you need. So you had the initial time, you had the final time. That would give you the difference between those two, would give you the period of the orbit in years. You'll need to convert the period in years to a period in seconds. The conversion factor for that is in your lab manual. It's 3.15 times 10 to the 7th seconds per year. Once you've and then notice as you click on the spectrum, it will tell you which binary system you have. So the system I'm currently looking at is binary star 2. To check your answers, you will be asked to put in the binary pair number. You'll be asked to put in the speed of the lighter star, right? This would be the higher speed, and the speed of the heavier star. That would be the lower speed you calculate. And then you'll be asked to enter the two masses of the stars, once again in solar mass units. For this particular lab, it will be very easy to calculate the speeds. You just need to pay very careful attention to the shift in those Doppler lines. And you've been doing that for a couple of weeks now, so you should be getting pretty good at making those measurements. The one point that you need to measure very, very carefully is that particular dip in the wavelength, right? So you need to be able to measure the time very, very accurately. And if your mass measurements aren't working out, I would suggest that you go back and make a very careful measurement of the period. Slow down the animation at the point when you see those spectral lines beginning to approach each other, so you're not trying to guess when that light first began to dim. And experience has shown that if the answers aren't checking, it's usually because your period hasn't been measured as carefully as it needs to be. Good luck with this lab. If you have any questions, please email me.